between 5 by 7 and 9 by 11. Anyone having doubt in such kind of questions?
No, ma'am.
No? Okay, fine. Then we will move on to the next exercise. Just a minute. Move on to the next exercise. Okay, so you know how x, let's say 2x plus 3x, this is equal to what? This is equal to what?
5x.
Yeah, 5x. Why is it taking so long for you guys? So similarly, if you just replace this x with something else, let's say 2 root 2 plus 3 root 2, this gives you, what should this give you?
5 root 2.
5 root 2, exactly. Okay, so this is how we add two irrational numbers. So you see, root 2 is irrational, right?
Yes, ma'am.
Similarly, 2 root 2 is also irrational. Any multiple of root 2 is going to be irrational. So any rational number
Multiplied to an irrational number is
multiplied
an
with an
irrational number.
irrational number gives you an irrational number. Remember this always. Okay. Acha, what if you multiply two irrational numbers? What do you think you will get? Will you always get an irrational number?
No. Not always an irrational number, not always a rational number.
Can you give me an
Depends. If
example
both of them are
them?
same, then they would get a rational number. But if they are not same, then they would get an irrational number.
Yeah. So, for example, if you have the same number root 2 multiplied by, okay, let's not talk about root 2. Let's talk about root 3. Okay. Let's say you have root 3 multiplied by root 3. It's the same number, right? So this gives you 3, which is rational. So you see, this is irrational.
Yeah.
This is irrational, but the product is rational. Then let's take an example when you have an irrational number multiplied with another irrational number, but the answer is this time it is irrational. For example, can someone give me an example of this when you multiply two irrational numbers, but their product is also irrational?
2 and root 2 and root 2.
Root 2 and root 2, when you multiply root 2 and root 2, what is their product?
2.
And 2 is what? Rational or irrational?
Rational.
It is rational, right? I am asking, give me an example where the product is irrational.
Root 2 into root 5.
Yes. So root 2 multiplied by root 5 is equal to?
We get root 10.
Root 10. And this gives us, this is an irrational
number.
Okay. Fine. So, acha, now what about if you have an irrational number and you add it to an irrational number? What will you get? What do you think you will get? Let's say
irrational
I add
number.
Yes, when you add two irrational numbers, you will always get an irrational number. Okay. This is 2 root 2. So when you add two irrational numbers, you will always get an irrational number. Let me write it over here. Sum of two irrational numbers . is always going to be irrational. Okay. And sum of a rational number with an irrational number. What do you think it will be?
Rational.
Irrational number.
It will always be again irrational.
Yeah.
Okay. So this was about the sum. Now let's recall what we just studied about the product. Product
Yes.
of two irrationals, when both of them are irrational, what did we just see? Will it be always irrational or what? What did we just see?
Irrational.
Look here and tell me. Look here. Yes. Two irrational numbers.
It'll either be rational or irrational.
It can be both rational and irrational, right? So can be rational or irrational. Okay. Now, product of a rational number with an irrational number. This is going to be, think about it.
Again, always an irrational number.
Always irrational. Okay. So these are the 4 cases. Kindly note them down. Here we had sum. Okay. So here we had sum. Here we had sum. Here we had product. Here we had product. Okay. And here it was always irrational. Here also it was always irrational. Here also it was always irrational. But only in one case you get can be rational or irrational, depends on the numbers. Okay.
Yeah.
All right. So you just saw how we did 2 root 2 plus 3 root 2. So in this case, treat root 2 just like you would treat any variable, right? When you treat x. So you do 2 plus 3 x. So you do it like this, right? When you have 2x plus 3x, you do 2 plus 3 and then you put the x in front of that. So this becomes 5x. So the same way we are going to treat operations on irrational numbers. Okay. So let's do one. Zen, unmute please.
Yes, ma'am.
Yeah. So tell me what will be 2 root 11 minus root 11. Yes, Zen, I'm asking you.
Two.
Okay, Zen, tell me one thing. What is 2x minus x?
Minus 2x.
2x minus, okay, what is x? X can be written as 1x, right? Yes or no?
Yes.
Now, can you tell me what is 2x minus 1x? Zen. Yes, Zen. Yes, Prishita.
Yes, ma'am. For the answer, like the first one, like 2 root 11 minus root 11 will be 11 root 11.
Root 11, right? Because it's just
Yeah.
2. It's just 2 minus 1. 2 minus 1 is what? 1. So it's 1 root 11, which is basically root 11 itself. Okay. Now let's do a one on multiplication. See, when it comes to multiplication, when you have, let's say you have root 3 into root 3, okay? Only when it's multiplied can the root be taken in common. You can write this as root 3 multiplied by 3, okay? Which is root, what is 3 into 3?
9.
9. And what is root 9? 3. Very good. Okay. So that is why we write root 3 multiplied by root 3, or in other words, root 3 square, because when something is being multiplied by itself twice, you write square, right? So that is why we write root 3 square equals 3, because of this. Now, similarly, if you have root 2 multiplied by root, let's say, root 5, what will this become? This will become root 2 multiplied by 5. So you take the root common, or you can say you can take both of these under the same root when they are being multiplied with each other. You can only do this in addition. Sorry, you can only do this in multiplication and division. You cannot do this in addition. Let's say if you have something like root 2 plus root 5. This is not equal to root 2 plus 5. You cannot do this.
Yeah.
Okay. So you cannot do this. This would be wrong. You cannot add both of them. This will just remain as it is. Why? You can simply this is why I asked you to compare it with variables. When you have a variable x and a different variable y. Yes. When the variables are different, can you add them? No, you can't. Let's say if you have 2x plus 3y, can you say it is equal to 5xy? No, you cannot, right? So you just keep them separate. But when it comes to multiplication of two different variables, like 2x
Yeah. So then we have
multiplied by, yes, then you multiply all of them with each other.
So 6xy.
Yes, this becomes 6xy. Similarly, you do the same thing when it comes to the under root, okay? So this becomes root 10.
Ma'am,
Yes, Abdur Rahman.
I found out when my unit test will start.
Okay. When
Yes.
will it start?
Oh, it only said the year. I think they haven't said when the test will start. But the subjects I have to learn for mathematics is chapter 5 and chapter 6.
Okay. All right.
Chapter 5 is introduction to
Euclid's geometry.
Euclid's geometry.
And chapter
And-
6 is lines and angles.
And chapter 6 is lines and angles.
Okay. We have done these two chapters, right? We have done these two chapters, and I believe you were present in both these chapters. Is that correct? Don't
Yes.
worry, we will have revision tests, okay? We'll have revision tests. All right. So is this part clear to everyone?
Yes, ma'am.
Yeah. So root 2 into 5, you can take the root as common, and you can multiply whatever is under the root. But when it comes to adding, you cannot take it as common. Both of them will just remain separate. Okay. So now let's do some questions based on these. Achha, you guys remember the identities, right? A plus B whole square, A
Ma'am,
minus
it's
B whole square.
confusing. Could you write it down?
identities?
Yeah.
Okay. So you have a plus b whole square. These are the identities that you already know. So I'm just going to write them is equal to a. Who's going to tell me what this is? A plus b whole square. Who will tell me?
A square plus B square.
A square plus
B
B
square.
square plus 2ab.
2ab. Very good. Then a minus b whole square.
A square plus b square minus 2ab.
Very good. Okay. A plus b multiplied by a minus b.
A square minus b square.
Yes.
Very good. Okay, so that's about all that you need to know. Okay. Now, when it comes to roots, just remember one more thing. We just discussed it previously. I'm going to write it again here. Root A into root B is equal to root A into B. Okay, please write this down. And yes, similarly, replace the multiplication sign with the division sign. Root A divided by root B, you can again take the root sign as common. It will become root A by B. Okay. Acha, one more thing. So we have completed Euclid's geometry. So now we will continue with, we will do more of the backup classes and less of the regular classes, because after we have completed from chapter 1 till chapter 7 plus Heron's formula, we have completed all of these. So I believe there is no chapter left for us to do, which is coming in your syllabus for your respective exams, right? There's no such chapter left. That is why we will not be moving beyond chapter 7 as of now. We will just be doing the chapters which you guys have missed. So right now we're doing the first one, number systems. Then we'll do polynomials, then coordinate geometry, then linear equations. And then we'll go to Heron's formula, which I believe is either 10th chapter or 12th chapter, I'm not sure. And then we will go to the lines and angles and triangles. Okay, is that fine for everyone?
Yes, ma'am.
I think we don't have to do triangles because all of you were present in that chapter. So yes, we will quickly be doing the backup classes. So we'll be focusing more on the backup classes and less on the regular classes. Is that okay? Because there's no point moving on to some new chapter now, because none of the other chapters will be coming in your exams, the chapters after triangles. Is that correct? Okay, let's do some questions.
Okay.
So let's do this. 3 plus root 8 multiplied by, or okay, before we do this, root 8 multiplied by root, let's say 12. How do we do this? What will this become? We will take the root in common, okay?
Yeah. 8 into 12.
What is 8 into 12?
96.
Very
96.
good. So it is 96. Now what we'll do, you can either just leave it at that, or what we are going to do now is, instead of writing this 96, just a minute.
Okay.
Do one thing. For this root 8 into 12, write this 8 as 2 into 2 into 2, and write this 12 as, what is the prime factorization of 12? 4 into 3, right? 4 into 3 can be written as 2 into 2 into 3. So please write it like this. Just a minute. There's some issue with the device. Just a minute. Yeah. So done till here, everyone. What we have done basically is we have taken 8 as 2 into 2 into 2, because 2 into 2 into 2 is 8. And
8.
we have taken 12 as 2 into 2 into 3, which is 4 times 3, which is 12. Okay.
12.
So now what we do is, just a minute. So now we pair them up. We say 2 into 2. So we make one pair of 2. So 2 into 2, that means 1 2 will come out. One of these 2's will come out. Okay. Meaning that both of them, they make a pair. And when they come out of the root, they will become just 1 2. Okay. Similarly, this 2 and this 2, they make a pair. So they will come out of the root. What is left inside the root? 2 into 3. So what does that give us? This gives us, what is outside the root? 2 into 2, that is 4. And what is inside the root? 2 into 3, that is 6. So this becomes 4 root 6. Is this clear to everyone?
So which number has pair that should go out of the root? Which doesn't have pair, it should go inside the root?
Yes, it should just, you will leave it if there's no pair for it.
Okay.
Okay. So when that's a pair of 2, so 2 will come out. That's another pair of 2, so another 2 will come out, like that. Okay. So let's do one more. Let's do a few more so that each of you is very clear with this. How about if I have, let's say, root, you have to simplify these roots. Okay. Let's say you have root, what is 72? Okay. Root 72. Munir? Yeah. So you can write 72 as what? Something multiplied by something. Can you tell me? $72 can be written as?
6 12.
Okay, fine. 6 into 12. Now, this 6 can be written as 3 into 2.
Yes.
And 12 can be written as, Munir?
4 into 3.
4 into 3. Now, this 4 into 3 can be written as?
2 into 2 into 3.
Very good. 2 into 2 into 3, right? So this is what we have written our 12 as. This is 12. Okay. Now, Munir, I want you to start making pairs. This 2 and 2 make a pair.
Yes.
So they will come out of the So this is our root. They will come out of the root, okay? Not both the twos. There's one pair of two, so that one two will come out. Fine.
Yes.
Now, any other pairs? Can you find any other pairs inside the root?
Ma'am, 3.
Very good. So there's this 3 and this 3, they make a pair. So this 3 with this 3. So 1, 3 will also come out. Done?
Yes, ma'am.
So what is left inside the root without any pair?
2, ma'am.
2 is left inside the root. So just going to write it like this. Root 2. So this gives you, what does this give you? What is 2 into 3?
6.
6. And under the root we have 2. So the answer is 6 root 2. Okay. All right. Avni. Yes. Let's do. Just a minute. Okay. Let's do this one. Root 484. I want all of you to try it on your own as well. This question is not just for Avni, it's for everyone. So you all please try, okay? 484. What do you think it will be? You can do the prime factorization also if you want.
Ma'am, 1 minute.
Yes, you can do the prime factorization.
Mom, this will make two pairs of two different numbers. No, one pair of two different numbers.
That's it.
Yeah.
Acha.
Yeah, so we have to shift one of the numbers outside, but which one I don't exactly know.
Okay. Wait a minute. Has everyone found the prime factorization of this? See, this 484 can be written as 44 into 11. Yes or no?
Yes.
Yes. So let's first write it as 44 into 11. Now this 44 itself can be written as 4 into 11, right? So this we can write it as 4 into 11 and into 11.
Yeah.
So what we have done here is this 44 we have written as 4 into 11 and the 11 is as it is.
Yeah, so we get 2 into 2 into 11 into 11.
Yes. Or another way is, you know that root 4 is 2, right? So instead of writing it once again as 2 into 2, you can just take it out and this becomes 2.
Okay.
Or if you want, you can just write it like this for your convenience. But we already know that root 4 is 2. So we're just going to take it out. Okay. And then there is a pair of 11s over here. So there's a pair of 2s and there's a pair of 11s. So 2 into 11. This gives us what? 22. Is this clear for all?
Yes.
Yeah.
Ma'am, I didn't understand the step after after the second step. I didn't understand.
Which part did you not understand?
After the second step.
Okay, wait a minute. You're talking about this one or this one?
No, the one on the right.
This one?
No, the left one, sorry.
This step you didn't understand, from here to here.
Yes.
Okay. See, I don't know what's the problem with this pen. It stops working again and again. Just a minute. I'm using a different device today, so it's acting up. Give me a minute. Okay. So see, Avni, if you're getting confused how we went from here to here, then don't go from here to here directly. Okay. You can write the 4 as 2 into 2. Yes.
Yes.
So just do it in that way.
Mm.
Okay.
Okay.
Just to explain you how we did that. See, if you have root 4, can you write this as 2? Yes or no?
Yes.
So root 4, you can write it as 2, right? That is why when I had root 4 into 11 into 11, I wrote this as this root 4. This is what I'm applying here. This root 4 can be written as 2, and then the same thing, 11 into 11. And now this 11 into 11, I'm writing it as 2 into 11.
Okay.
Are you understanding now?
Yes.
Okay. Okay. So now let's do some questions. I think you all are pretty aware of how to do this multiplication now. Let's do some questions. If you have 3 plus root 5 multiplied by 5 plus root 7, or not root 7, let's take some other number, root 11. How can we do this? This is the same thing what we used to do. First, take this number, multiply it with this number. Then take the first number, multiply it with this. Then take this number and multiply it with this.
Ma'am, we will use identity 5, right?
You can use, there's no such identity that, yeah, Achha, you're talking about the textbook. Yeah, that's not an identity exactly. That's the same thing which you have been using till now. When you have any two numbers, any two brackets, something plus something, and something plus something. You just, the way you multiply them, the same thing you're going to do here as well. So let's just look at all the steps, okay? So first, 3 multiplied by 5. What is 3 multiplied by 5?
15.
15 plus 3
5
multiplied by,
yeah, okay.
yeah, 3
33.
multiplied by root 11 is 3 root 11.
Root, yeah,
Then this root 5 multiplied with 5.
by, yeah,
That is
5 root 5
5 root 5. Then we have
plus
root
root
5
5 into
multiplied
root
with
11.
root 11, which is
So
root,
root 55.
yes, root 5 into 11, which is root 55.
55.
Okay. So
Okay.
I'm gonna write this again. That's it. You won't be able to simplify it further from here. Okay. Munir, please unmute.
Yes, ma'am.
Yes. Let's do the next one. Munir. Yes. Munir, which identity do you think you can use here? Do you remember some identity like this? What does
A
this
square
remind
minus-
you of? Very good. A square minus B square. So this is your A plus B multiplied by A minus B, right? So
Yes,
this
ma'am.
is equal to A square minus B square. So this will be what square minus what square again?
12 square.
12 square minus
12 square minus 5 square.
root 5 square. So what is 12 square? $144. Come on, you're supposed to remember what is 12 square, okay? Minus root 5 square. Now the square and the root will get cancelled with each other. So you are left with 5. So this becomes what? Yes, Munir. 139. This becomes 139. Okay. Let's do another one. Okay, Zen.
Yes, ma'am.
Yeah. So the next one we will be doing together. But then please keep yourself unmuted for the rest of this question, okay? Okay, Zen. What is root 7 plus root 2 whole square? Yes, Zen. Zen, unmute.
Uh,
Zen, do you remember any identity related to this?
uh, a plus a plus b square.
A plus B whole square. You're supposed to say whole square.
Uh,
Yes. What is that equal to?
a plus b whole square whole equal a square
Yes.
plus 2ab plus b
Yes.
square.
Very good. So this will now over here, what is A and what is B?
7 is a.
7 is A or root 7 is A?
Root 7 is a and root 2 is b.
So what will be your A square plus 2AB plus B square? It will become
Root 7 root 7 square plus 2.
plus 2AB. What is A?
Root 7
What is B?
root 2.
And what is B square?
Root 2 whole square.
Root 2 whole square. Now Zen, tell me what will this become? The first term.
7 plus 2.
Not 7 plus 2. First you say 7. This is the first term is 7. I'm asking for the first term only. Now what will the second term become? It's not 2. This entire thing is the second term. Okay? Is that
14,
okay? What is it?
14.
2 root 14, not 14. Because look at this root, this is root 7 into root 2. Okay. So that is root 7 into 2. Don't forget the root. Then what is the third term, Zen?
2.
2. Yes. So the square and the root get cancelled and we are left with 2. Now, Zen, can we add these two things?
Yes, ma'am.
Because they are like terms. So we can add them. So this gives me 9 plus what else is there?
2 square 14.
2 root 14, not square 14.
Sorry, root 14.
This is the final answer. Okay. Everyone
ma'am.
done till here?
Yes, ma'am, done.
Okay. Acha. Now let's come to a topic called rationalizing the denominator. See what happens. Why do we rationalize the denominator? First of all, let's see why we do it, then we will say what it actually is. Okay, let's say you have a fraction like 1 by root 2. Okay, on the other hand, let's say you have a fraction 1 by 2. Okay, so 1 by 2 is something that you can show on the number line, right? 1 by 2 means you have this 0. Now listen very carefully about what I'm going to say. You have 0 over here, you have 1 over here. 1 by 2 means, first of all, when the denominator is 2, what does it mean? Let's say if I have a pizza and I say I want 1/4 of this pizza, then you immediately know when you look at the denominator, you will say there is 4 in the denominator. That means I should cut this pizza into 4 slices. Yeah, that's what the denominator means.
Yes.
And if I say, you will look at the numerator, which is 1 in this case, and you will say, okay, numerator is 1, means that I need 1 slice out of these 4 slices. So if I have a fraction 1 by 2, it means you take this length, you divide it into 2 parts, 2 equal parts. Each part will be 1 by 2. Okay, and this length between 0 and 1 is called 1 by 2. But what if you have a number like this, 1 by root 2? Does it really make any sense? Because root 2, which is the denominator is supposed to tell me how many pieces I am supposed to have, how many slices I should have, or how many pieces of that particular length I should have. But there is, how can you make root 2 number of pieces? See, you can make 2 pieces, you can make 4 pieces. How can you make root 2 pieces? That doesn't make sense, right? That is why we say I am not going to have any irrational number in my denominator. I want only rational numbers in my denominator. So what we do is we use a concept called rationalizing the denominator, and see how that happens. Is if you have 1 by root 2. Okay, so for us to let's have it make some sense. So what we'll do is we will multiply above and below by root 2. Now see what magic happens over here. The numerator will become root 2, right? 1 multiplied by root 2 is root 2. And what will the denominator become?
Two.
Yes, it will become 2. So the denominator becomes 2 because root 2 multiplied by root 2. Now, does this make sense? Yes, it does. Why? Because you take the number line 0 and 1. Okay, you make 2 parts of it because the denominator says 2. So you make 2 parts of it. Numerator says I want root 2th of this. So this is 1 by root 2. This is going to be root 2 by root 2. Sorry, root 2 by 2. That means I need root the distance root 2 from 0. Does that make sense? So this is something that is going to make sense, and this is why we rationalize the denominator. So let's say if I have something like 2 by root 3. Now again, the denominator is an irrational number, so I need to rationalize it. What do we multiply it with so that the denominator becomes a rational number? Yes.
Mom, we have to multiply it with the denominator on
Itself.
both the
Yes.
numerator and denominator.
Yes. So we will
Yeah.
multiply it with root 3 by root 3. So what will the numerator become?
3.
2 root 3.
2 root 3. The numerator will become 2 root 3.
2 root 3 and
And
the
denominator will become
3.
3.
3. So this we have rationalized the denominator. Munir? Munir?
Yes, ma'am.
Yeah. So Munir, tell us how will we rationalize the denominator of 3 by root 5? How will we rationalize the denominator of 3 by root 5?
Now I don't know.
Acha, were you listening when we were doing the first two questions? The 1 by root 2 and 2 by root 3?
Yes, ma'am, but I didn't understand.
Didn't understand. See, the question is, what should we multiply it with so that this thing, the denominator over here, comes out to be a rational number? How will it become a rational number? It will become a rational number only if you multiply it with root 5. So if you're multiplying it with root 5, you have to do the same thing in the numerator as well. You can't just do it only in the denominator and leave it like that. You have to do the same thing above and below, numerator and denominator. Okay. So
Yes.
now, Munir, what does the denominator become?
5.
And what does the numerator become?
3 root 5. 3 root 5.
3 root 5. So do you know how to rationalize the denominator of such a fraction now, Munir?
Yes, ma'am.
Yes. Okay. And please pay close attention in the class. Okay. Okay, now let's see another type of question. Let's say you have 7 by 2 root, let's say 2 root 11. Okay. Now what do you do? What should we multiply it with?
Twenty-two.
22.
No,
Okay,
no.
let's one sec. Let's multiply it with 22 and see what happens. Okay, it's okay. There's no harm in trying and experimenting. So if you multiply it with 22, it will become 154 by, what is 2 root 11 into 22? What you will do here is you multiply the rational with the rational and the irrational with the irrational. So what does that give you? It gives you 44 root 11. So you have 44 root 11. I still have a root in my denominator. So that means this trick is not going to work. We have to try something else now. Think.
The root 11.
Very good. We have to multiply it with root 11. Now, Zain. Abdul Rahman,
Yes.
what will the numerator become if you multiply it like this? Numerator.
Mm,
Yes, quickly.
yeah.
Yes, Avni. You're raising your hand.
7 root 11
By
by 2.
2 into something, not just 2.
11.
2 into 11.
2 into 11. Because that is root 11 into root 11, which becomes
It's
11.
correct.
So this becomes 7 root 11 by how much? 22. So this is the answer. Okay.
Ma'am.
All right. Let's do a different type of question. 2 by 5 plus root 3. Now, what do you think we should do here? Avni, what do you think we should multiply it with over here?
Root 3.
Okay, let's see what will happen if we multiply it with root 3. What will the numerator become?
5 into 3.
No, numerator. What will the numerator become?
Root 3.
Bache, numerator.
Two root 3.
Very good. 2
Ma'am,
root 3.
Ma'am
Right?
said that.
You said 2 root 3? Okay, I'm sorry, I didn't hear you. And what will the denominator become?
Uh, 5 into 3.
5 into 3. Okay, let's look at it very carefully, okay? We have 5 plus root 3. This entire thing is being multiplied with root 3. Also, do I have to remind you guys in every class to switch on your videos? Yes. Now, what does this become? You have 5 multiplied by root 3, which is 5 root 3, plus root 3 multiplied by root 3, which is
Root 3 square.
root 3 square, and that is root 3 square is
9.
root 3 square is 9.
No.
Then root 3 square is how much?
3.
3, right? The root and the square gets cancelled. So this is 3. So here, what have we basically done? We have gotten this in the denominator because 5 root 3 multiplied by root 3. So our denominator becomes 5 root 3 plus 3. But we still have an irrational number in our denominator. So that's a problem, right? Are you understanding where the problem is happening?
Yes, ma'am.
So what do you think we should multiply it with? What do you think that 2 by 5 plus root 3 should be multiplied with so that we can get rid of the irrational part of it? Okay. Let's look at the identities. Where did our identities go? There you go. So let's say I change this. Let's say I take root A and root B everywhere. Okay, now pay close attention. So if I have root A plus root B whole square, this becomes root A whole square. So the root and the square get cancelled. So I am left with what? A. Root B whole square. So root and square again get cancelled. But here you are left with root AB. Yeah. Similarly, this becomes A plus B minus 2 root AB. But in this case, you are left with only A minus B. There is no root part left over here. Are you understanding what I'm trying to say? That in both of these identities, the first one and the second one, you have some root portion remaining. This portion, the irrational portion, is still remaining. But in the third identity, you don't have any irrational part remaining. So let's try to make use of the third identity. So what we are going to do, yes, Avni.
Can we multiply 5 plus root 3 both top and bottom?
Okay, So you are saying let's multiply it with 5 plus root 3. Now let's do one thing. Let's see it over here. What will happen? Okay, 5 plus root 3. We already have in the denominator 5 plus root 3. Yes.
Yes.
So 5 plus root 3, you are saying let's multiply it with 5 plus root 3. Okay. Now this is a plus b whole square.
Hmm.
Yes or no? So 5 plus root 3 multiplied by 5 plus root 3 is 5 plus root 3 whole square. Now you apply the a plus b whole square formula. What will this become? What will this become?
Just a second, like I'm solving it.
Okay. Okay. Tell me step by step. What is the next step after
So
this?
5 square plus root 3 square plus 5 root 3.
Plus 2
5
into
3,
5
yeah.
into root 3. So 5 square is
25
25. Munir, video
plus 3,
plus 3
yeah,
plus
3. Okay, so plus 10 root
10
3.
root 3. So Avni, do you see what we are going to get? We are going to get 28 plus 10 root 3. Again, we are left with the root part. This is what I was just telling you over here, that if you take this identity, the first one or the second one, you are still going to be left. Oops. Where did we go? Yes, you are still going to be left with some root portion. That is why we are supposed to take the third identity. And what is that? What are we supposed to do? If you have 5 plus root 3 in the denominator, multiply the fraction with 5 minus root 3. Getting it? Multiply the fraction with 5 minus root 3 on both in both the numerator and the denominator, and tell me what you are getting. Munir, yes, let's do it step by step. What does the numerator become, Munir? Yes? I couldn't hear you. Repeat.
1 minute, ma'am.
I'm 10 minus root 3.
Yeah, the numerator is going to become 10 minus 2 root 3. Why? Because this 2 is being multiplied with both of these numbers.
Yes.
Yeah, it's 2 into 5 minus root 3, which is 2 into 5 minus 2 into root 3. Please don't make these silly mistakes in your exams, okay?
Okay, ma'am.
Because you're going to, for no reason, you will lose marks then.
Ma'am, then we'll add 5 plus 5.
Which 5 plus 5 will? Why will we add them? This is 5 plus root 3 multiplied with 5 minus root 3. How will we add
Oh,
them?
yes. Yeah, we'll multiply 5 into 5.
Bache, which which identity do we have here? 5 plus root 3, 5 minus root 3. Does that remind you of some identity? Who will tell me? We just now discussed it.
A plus B, A minus B.
Very good,
plus-
Munir. So this is A plus B, A minus B. A plus B multiplied by A minus B, this is equal to? This is equal to what? What does the identity say? Forgot so soon? Bache, what is A plus B into A minus B? Okay, look
square
here and
minus
tell.
B square.
Yes, it is A square minus B square, right? What is A?
5.
A is 5. So it's 5 square minus what?
Root 3 square.
Root 3 square, yes. So 5 square is?
10.
5 square is 10.
No.
25.
25 minus root 3 square is?
3.
3. So what is 25 minus 3?
22.
22. Very good. So in the denominator, what are we left with? Can you see how the root part of it vanished?
Yes.
Yes. So in the denominator, we are left with 22. Now you may ask, but in the numerator, we still have a root. Obviously, you're going to have a root in the, if you are transferring the root from denominator, it will appear somewhere else. It will appear in the numerator. It is going to be there, but our aim is to eliminate the root from the denominator. Okay. That's why the name of this concept is rationalizing the denominator. If it's there in the numerator, no problem. It just shouldn't be there in the denominator. That's our main concern. Okay. So in the numerator, can we take 2 as common? 10 and 2. So 2 as common, it becomes 5 minus root 3. And in the denominator, we have 2 multiplied by 11. So this 2 and this 2 get cancelled. We are left with 5 minus root 3 by 11. This is our final answer. I mean, it's okay if you leave it at this as well, but it's better if you solve it till here and you simplify it by cancelling any common terms. Okay. Is this clear to everyone?
Yes, ma'am.
Okay. Okay. So now let's do another question. A similar question. Let's do it together. Okay. Let's have 3 by 3 by root 7 minus 2. Okay. What are you supposed to multiply it with?
Root 7 plus 2.
Very good. Root 7 plus 2. Root 7 plus 2. So here numerator becomes
3 root 7 plus 2.
3 multiplied by root 7 plus 2 divided by, what does the denominator become?
$49.
Very good. So it will become root 7 square minus 2 square. Yes,
Yes.
a square
Yeah.
minus b square. So now let's solve the numerator. What is the numerator?
5 root,
Hmm?
no,
What is
6 root 7.
Bache, what is when you say 3 multiplied by root 7? This is 3 into root 7 plus 3 into 2, right?
Hmm.
So what is 3 into root 7? 3 root 7
Yes.
plus now plus
5.
3 into 2. What is 3 into 2?
6.
6. Avni, is your doubt cleared?
Ma'am.
Now denominator. Let's come to the denominator.
49 minus 2.
49 minus 2. What is 2 square?
Oh, 2 square, yeah, 4.
4. Now solve the denominator and tell me.
Ma'am, 14.
45
45. So this is 3 root 7 plus 6
plus 6 by 45.
by 45. You can take 3 common in the numerator. This becomes 3 multiplied by, I mean, we didn't have to do this, but anyways, 3 root 7 plus 2, but divided by 3 into 15. So this and this gets cancelled. So we are left with 7
Root 7 plus
root 7 plus
2
2 by
15.
15. This is the answer.
Yeah. Okay, ma'am.
Okay. Let's
Yes,
do
ma'am.
another question now.
Okay, ma'am.
Let's do 6 divided by root root 7 minus root 5. What do you think we should do here?
Ma'am, we have to multiply both the numerator and denominator by root 7 plus root 5.
Very good. Root 7 plus root 5, root 7 plus root 5. Okay.
Then we
So
will get root like 6 root 7 plus 6 root 5
by
root
root
7
7
square
square
minus root 5
minus
square.
root 5 square. Very good.
Ma'am, so the denominator will be 7 minus 5.
Which is
Very good.
equals to 2.
Which is equal to 2. So
Yeah.
the numerator is going to be this by 7 minus 5. I'm just writing step by step so that if
Yeah.
anyone has any doubt, you can look at these steps, okay? Divided by
And
2.
then we
This-
will cut the
Yeah.
2 and 6. So 3 root 7 plus 3 root 5
3
will
root
be the
7
final
plus
answer.
3 root 5. Very good. Done. Shall we move on to the next question?
Yes, ma'am.
Let's do, let's say 4 by 6 plus 3 root 2. Now, what should we multiply it with?
The same thing which is on the denominator but minus.
But minus. Very good. So, 6 minus 3 root 2. 6 plus 3 root 2. Okay. So, numerator will become?
The denominator also should be subtract,
Oh,
right?
I'm sorry. Yes. So, what will the denominator become? Who will tell me?
6 square plus 3 root square.
Minus.
Yeah, minus.
Minus
3 root square.
3 root 2 whole square. What is it called? Whole square.
Root square.
Okay. Because if you say 3 root 2 square, then someone might think, is she talking about 3 root 2 square? That's why you say 3 root 2 whole square. Okay.
Yeah. So that becomes
36.
18. So
Okay. I am going to write the the numerator later on. Let's talk about the denominator. 36 minus
18.
18. Why 18? Because see, 3
Because
root
3 into
2,
3 and root 2 into root 2.
this can be written as 3 3s are 9 into, because this square is for the 3 also and for the root 2 also. So,
Ma'am, so we can't cut the root and square here.
yes, it will be cut. It will be root 2 whole square, right? So now it will get cut. You can't cut it like this because this will become 3 into 2, which is not correct, because the square is there for both the 3 and the root 2. So it will be 3 square into root 2 square, which is 9 into root 2 square, which is 18. Are you getting it now, Avni?
Yes, ma'am.
So this is 18. So 36 minus 18. So now this is 4 into, I'm going to take 3 as common. 2 minus root 2. I took 3 as common from over here. From here. From here and here, I took 3 as common. Okay. So here we have 4 into 3 into 2 minus root 2 by 36 minus 18 is 18. So I'm going to do it like this. Just going to make some cancellations. So this is 2 into 2 minus root 2 by 3. Okay.
Yeah.
Ma'am, do we have extra class tomorrow also?
No. Done. Shall we move on to the next question?
Yes, ma'am.
Okay. So now we have a different type of question. I mean, it's the same thing, just the numerator becomes a little more complicated. Yeah. Now,
Ma'am, the denominator with both of them, but minus.
but minus. So root 3 minus root 2 by root 3 minus root 2. You just have to multiply it with the same thing which is in the denominator, but with a minus sign. Okay.
Yes.
With this, you don't have to look at the numerator at all. No matter what the numerator is, you just have to just look at the denominator. Fine. Now what does this become? Now over here you have to do some calculations in the numerator as well. Now what does the denominator become? Who will tell me?
3 minus 2.
Yes, it
Which
will
is
become
equals to
root
1.
3.
So
Yeah, root 3 square minus root 2 square, which is 3 minus 2, which is 1. So now let's talk about the numerator. one by one, okay? We will do first term of the first bracket multiplied by the first term of the second bracket, and then so on, okay? So this will become root 3 into root 3 plus root 5 into root 3 plus, or rather minus, root 3 into root 2. Then again minus root 5 into root 2. Any confusion? Anyone till here? In this step, any confusion?
No, ma'am.
No, ma'am.
Munir, Abdul Rahman, Abdul Jabbar. Okay, Abdul Jabbar isn't here. Munir, Abdul Rahman, any doubts?
No, ma'am.
Okay. Denominator, as we discussed, it is 3 minus 2 because this square and this root get cancelled. Square and root get cancelled. So we are left with numerator. Munir, what will the numerator become now?
Ma'am,
Yes, Avni.
we can make the 3 and 3 a pair, right?
Yeah, so what does it become?
So root 3 square
And
plus
that is root
that's
3
3.
square is 3. Yes. Then the next part.
Yeah,
What does it become?
root 5 and root 3 square.
How is it root 3 square? It's root 5 multiplied by root 3. So that is root 5 into 3.
Yes.
Yeah. Root 5 into 3. And what's 5 into 3?
15.
15. So that's root
15 square.
15. Not 15 square. Where's the square over here? It's just 15.
Yeah. Okay.
Yeah.
Now next step, next term. What is the next term?
Root 6.
Root 6. Very good. Root 6. It came a little small. And don't forget the plus and minus signs, okay? Then the next term,
Root 10.
root 10. Divided by
12.